Let us discuss some of the questions related to the metallurgy, which is based on to the IGSO level. Now, here is the question number 1. Now, we have to check among the given following ores which contains both calcium and the magnesium. Which contain both calcium and magnesium. We have to check it. Now, options are, first one is the limestone, second one is dolomite, third one is chalk, and the fourth one is feldspar, or we can also say fluorspar. Now, how we recognize among these ore which ore contains calcium and magnesium with the help of their formulas? As we know that the formula of limestone is what? CaCO3. Does this ore contains magnesium? No. Calcium and magnesium, it contains only calcium. Dolomite, which is CaCO3 dot MgCO3, that means it is a double salt which contains both calcium and magnesium. Now chalk, which is again the another name of CaCO3, it is also termed as marble, that is CaCO3 contains only calcium. Fluorspar or feldspar, which is calcium fluoride, again contains only calcium. So here is only a one ore, dolomite, which contains both calcium as well as magnesium. Now we'll see on to another question. Now, how do we obtain chromium? By reducing its concentrated chromite ore. What is the process of extracting the chromite from its chromite ore? As the ore here is chromite, which contains chromium as metal. Now, this metal lies in the middle of the reactivity series. How will obtain this metal? Will obtain this metal by reducing its chromite ore with the help of the reducing agents. Now, what all reducing agents will be able to reduce the chromite ore? All those metals from aluminium which are present above chromium in the reactivity series. So, we are able to reduce this chromite ore by using aluminium as a reducing agent, and it will give chromium plus Al2O3. In this way, we'll extract the chromium from its ore. Now, third question is, what will you obtain by fusing Na2CO3 with AgCl? What will you obtain by the fusion of AgCl with Na2CO3? So, we'll write the reaction between AgCl and the Na2CO3. AgCl, when reacts with Na2CO3, what sort of reaction will it be? It will be a double decomposition reaction, as here Ag will be represented as A, Cl will be represented as B, Na will be represented as X, and CO3 will be represented as Y. So, which will be a positive radical, positive radical, and a negative radical. Now, here chlorine gets displaced from the AgCl and CO3 gets combined with the Ag so as to form the Ag2CO3, and here the carbonate gets displaced from Na2CO3 so as to form the NaCl. This is a double displacement reaction. This Ag2CO3 which is obtained during the reaction, it undergoes the decomposition reaction. So on heating, it forms Ag plus half O2 plus CO2. These are the substances which will be obtained by fusing the AgCl with Na2CO3. Now we'll see the next question. Suppose there is a question. The metal X is prepared by the electrolysis of fused chloride. It reacts with hydrogen to form colorless solid from which hydrogen gas is released on a treatment with water. The metal will be, we have to choose the metal from the given option. Option given here are A is what? Aluminium. B is what? Calcium. C is what? Copper. And D is what? Zinc. Now, here four options are given, that is aluminium, calcium, copper and zinc. Now, out of these four options, the fused chloride, the metal X is prepared by the electrolysis of the fused chloride, and it reacts with the hydrogen so as to form the colorless solid from which the hydrogen gas is released on a treatment with water. Now, what all metals, firstly, what we have to focus is what all metals will be able to obtain with the help of electrolytic method. Those metals are those which are present in the top of the reactivity series of the matter. That means metal especially which are present or belong to first group, second group and the third group of the periodic table. So there will be a choice between option A and option B. Now, but the question is given about the fused chloride, fused metal chloride. So more appropriately it will be a calcium. Let us focus on to the reaction. Fused chloride we have taken. This CaCl2 undergoes the electrolytic process so as to obtain the calcium with the chlorine gas. This calcium gets deposited at the cathode and the chlorine gets deposited at the anode. As it has a tendency to lose the electron, now by losing the electron, the calcium ion by losing the electron converts into calcium. So we can say that reduction takes place at cathode and oxidation takes place at anode. This calcium has a tendency to react with hydrogen. When it reacts with hydrogen, it forms the hydride, because here calcium acts as a matter. It has a tendency to lose the electron. It has a tendency only to lose the electron. So it exists here in a Ca2 positive state, and calcium has a tendency to gain as well as to lose the electron. As here calcium is losing the electron, in this particular situation hydrogen has a tendency to gain the electron and come into the H negative state. This H negative state of the hydrogen is termed as what? Hydride. So they both will combine so as to form the CaH2. So its chemical name will be calcium hydride and its common name is hydrolith. Why it is known as hydrolith? It is a hydro means what? It's related to hydrogen. Lith means what? Lithosphere, that is atmosphere. So it is considered as a source of hydrogen. That's why the most appropriate option and the best option will be CaH2, as CH2 is a source of hydrogen, because when this CaH2 is dissolved into water, it gives CaOH whole twice plus H2 and the hydrogen gas is released. So the option will be calcium. Now we'll see the next question. Question number 5. Now again certain ores are given. We have to check whether among the given ores which ore is not the ore of the magnesium. Among the given ore, which of the following is not an ore of magnesium? We'll see the options. First one is carnallite. Second one is magnesite. Third one is dolomite. And fourth one is gypsum. Again, we'll go through the formulas of these particular ores. Carnallite, as we have discussed, carnallite is what? It's KCl dot MgCl2 dot 6H2. That means it contains magnesium. Magnesium is present. Magnesite is what? MgCO3 again contains magnesium. Dolomite is what? We have seen just now. It's CaCO3.MgCO3. Again it contains magnesium. And last but not the least, that is gypsum. It's CaSO4 dot half H2O. Here magnesium is not present. That is a ore which do not contain magnesium, and we have to find among the given ore which do not contain magnesium. So this will be the option. Again the same question. Certain statements are given, and we have to check whether they are true or false. Whether the statement is true or false. First one is first statement is in Goldschmidt thermite process aluminium acts as a reducing agent. It's given in gold thermite process aluminium act as a reducing agent. B is magnesium is extracted by electrolysis of aqueous solution of MgCl2. Extraction of the lead is possible by smelting. Extraction of lead is possible by smelting. And red bauxite is purified by Serpex process. Is it true or not? First option is what? In a Goldschmidt thermite process, aluminium acts as a reducing agent. Let's check the reaction related to first question. In this process, the chromite ore reacts with aluminium, which on heating gives Cr plus Al2O3. Here, aluminium acts as what? Reducing agent. That means statement first is true. Now magnesium is extracted by the electrolytic solution electrolysis of the aqueous solution of MgCl2. Let us check how the magnesium is extracted. The magnesium is extracted by electrolysis of fused MgCl2 and NaCl. Magnesium is not alone extracted by the electrolysis of an aqueous solution of the MgCl2. We require a fused MgCl2 and NaCl. So this option will be what? False. Extraction of the lead is possible by smelting. Yeah. Let us see. PBS. This is a sulfide ore. When roasting is carried out in the presence of air, it gets converted into the lead oxide. And this lead oxide, in the presence of the carbon, is a reducing agent. It gets reduced into lead plus CO. And this process is carried out in the this process is termed as a smelting process. Thus we can say that extraction of the lead is possible by smelting. That means it is a true statement. And last is what? Red bauxite is purified by the Surfax process. No, it is purified by Bayer's process. So the above statement will be